Chapter 6, Lesson 2, Notes, Graphing Linear Equations Using Substitution. A linear equation is an equation whose graph is a line. A linear equation is in the form of y equals mx plus b, where m is the slope and b is the y-intercept. A few examples of linear equation is y equals 60 times x, y equals x plus 30. But remember, this has an invisible 1 in front of the x. You have y equals negative x plus 10, and this also has an invisible 1x plus 10. You can graph a linear equation by making a table of ordered pairs. We will be doing this to plot the ordered pairs and able to create the graph. You need to remember that x is an independent variable, y is a dependent variable. That means that your x will get substituted into your equation to determine the value of y. Let's take a look at a couple examples together. Number 1, what we will be doing is substituting the value of x into the equation given to determine the value of y. I will write the equation 2, but instead of x, I will put negative 2 plus 1. I do like to solve each step so that I can follow along with what I'm doing. 2 times negative 2 is negative 4 plus 1. Now I have negative 4 plus 1 is negative 3. You will have to remember your integer rules. I'm going to do the same thing with negative 1. 2 times negative 1 plus 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. I'm going to substitute 0 in. 2 times 0 plus 1. 0 plus 1 is 1. Substituting 1 into the equation as well. 2 times 1 plus 1. 2 times 1 is 2. Plus 1 is 3. The last one is 2 times 2 plus 1. 2 times 2 is 4. Plus 1 is 5. I want to go back through and make sure that you can see that the x has been substituted into the equation so that we can find our output y. We will use these coordinates, negative 2, negative 3, negative 1, negative 1, 1, 3, 1. I already got that one. Nope, that one was 0, 1, 1, 3, and 2, 5. When you are plotting coordinates, you always start at the origin where the x and y axis cross. The x tells you whether or not you go left or right. So for our first coordinate of negative 2, negative 3, it means I go left 2, down 3. Go back to the origin. Left 1, down 1. Go back to the origin. 0 means you're not going left or right, but you go up 1. The next coordinate is 1, 3, and because it's positive, you're going to go right 1, up 3. I am going to use something with a straight edge. It doesn't matter what it is. Your student ID, a sheet of paper, a folder, a card, whatever you have handy to make sure that your line is straight. Let's take a look at number 2. I would like to rewrite the equation to put the invisible 1 in, so y equals 1 times x minus 3. And remember, I'm going to do the same thing where I'm going to substitute x. All these values of x that they give us, I'm going to substitute it into the equation to determine the value of y. So you have 1 times negative 2 minus 3. 1 times negative 1 minus 3. 1 times 0 minus 3. 1 times 1 minus 3. And 1 times 2 minus 3. Again, the only number that is changing in any of these equations is the x value. I will solve these expressions. 1 times negative 2 is negative 2, minus 3 is negative 5. 1 times negative 1 is negative 1, minus 3 is negative 4. 0 minus 3 is negative 3. 1 times 1 is 1, minus 3 is negative 2. 1 times 2 is 2, minus 3 is negative 1. I will then go to the graph and plot the points. And remember, you will always start at the origin before you go left or right. Starting at the origin, I'm going to plot the first one, negative 2. So I'm going to go left 2, down 5, 1, 2, 3, 4, 5. Go back to the origin, left 1, down 4, 1, 2, 3, 4. Go back to the origin. 0, I'm not going left or right, but I go down 3. Go back to the origin. Right 1, down 2. Go back to the origin. Right 2, down 1. And again, I'm going to use any straight edge I can get my hands on. ID, folder, sheet of paper, ruler, it doesn't matter. It's a lot easier to connect the dots when you have something you can use. Does anyone have any questions at this time? Let's take a look at number 5. And although number 5 is in a word problem, I do want to point out that they do give you the equation we will be using. So we're going to solve number 5 exactly like we did 1 through 4. I'm going to, instead of using h though for each of these, I'm going to substitute in the value that they are giving me. So the first one has 9 times negative 1 plus 5. The second one is 9 times 0 plus 5. The third one is 9 times 1 plus 5. Then you have 9 times 2 plus 5 and 9 times 3 plus 5. I'm now going to take the next step to solve these, but I want to point out first that all I'm doing is writing the same equation over and over and over again, just substituting in the value of x that they have given. 9 times negative 1 is negative 9 plus 5, that is negative 4. 9 times 0 is 0 plus 5, that is 5. 9 times 1 is 9 plus 5 is 14. 9 times 2 is 18 plus 5, 23. 9 times 3 is 27 plus 5 is 32. The coordinates are negative 1, negative 4, 0, 5, 1, and 14, 2, and 23, and 3, and 32. Our graph that they gave us is not labeled, so we will be labeling it. Remember that time, this one's measured in hours, is usually the independent x variable. Money, which is measured in dollars, is most often your dependent or y variable. I am going to count the hours by ones, and since this is only the upper right hand corner of our coordinate grid, we know that the origin is right there, right where the x and the y cross. I'm going to count my y's by 5. I am just choosing 5 to give me a little bit of space. I know that it has to be more than 1 because it wouldn't fit. I could have used 2, I could have used 4, I just chose 5. Going to go ahead and plot our points. I can't do negatives because it's not on our graph, so I'm going to plot this one, 0, 5, 1 and 14, 2 and 23, 3, and 32. And again, I'm going to use a straight edge to connect my dots. Do we have any questions at this time?